So the last of the set of foreign keys that we need to handle are the one relating to the reading table. Okay, so the last three bullets on this slide, I believe 15. Okay, and they're going to be right here in the reading table. So I'm going to get back to the final ERD again and show you that's the bottom right of the slide. Okay, I'm going to position it as best as I can so I can reference it. Okay, and I'm going to then go into the create table. I'll notice that the read time doesn't have a data type, which should be date or date time, or really time, I believe it was. It doesn't really matter right now because we're really just mostly dealing with relationships at this point. But nevertheless, it should have there. And I think I've noticed another one missing right here. Subsidize, yes, no. How about char 1, y for yes and for no. So back to the relationships, okay? Back to the relationships. Let's start first with a meter is read by a reading, okay? So clearly meter is required for a reading, okay? Meter is required for reading, or that reading is optional for the meter. Okay, because meter is required for the reading, and meter number will become a foreign key in the reading, which is a child table. See the crow's foot symbol here. That meter number in the reading table cannot be null. So let's insert that one first. The order doesn't particularly matter. After the PK reading primary key constraint, constraint is the FK meter foreign key. Okay, and it's the meter NO, which of course I have to insert. References meter and meter number primary key. Okay, so I have to insert it, and I'm going to do that here. Meter NO is again integer and not null, as we just discussed. Okay, then the relationship between the meter and, let's say, employee table right here in the bottom right corner, right? Employee performs a reading against the child table, so the employee number ends up in the reading table as a foreign key. And because the employee is required for a reading, we are, talked about that several recordings ago. There are no automatic readings. Again, the not null needs to be there. So EMP and O integer not null, and becomes a constraint FK employee foreign key EMPNO references employee table and EMPNO primary key. Okay, finally, oops, I already have a comma. Finally, the last relationship includes, okay, the reading is included on the bill, or bill includes a reading, okay, and the reading is required, okay, for the bill, but bill is not required for the reading because bill is the parent table. This is 0 right here, or this optional relationship, or it means that the bill number that becomes the reading table foreign key does not have to be not null. In other words, it does not have to have a value, because there are readings, as we indicated, they're not necessarily associated with the bills but have other purposes. Okay, and we're going to touch this briefly at the end of the presentation. So let's just put it in bill NO. It's an integer without this not null constraint, and then finally the last line of code, constraint FK bill foreign key bill NO references bill table and bill NO primary key there. Okay, I believe this is probably more or less, there's nothing going on down here. For these two tables, we have all the relationships implemented, and I believe the code is probably 99% correct. There were a couple of data types they were missing, because the emphasis here is not as much on these as it is on the entities, their primary keys, and then the relationships as captured by the multitude of foreign keys we just sort of inserted here. Right, back to the presentation. We went through the 1 to m basic conversion rule number 2, 1 to m relationship rule, and all the foreign keys just defined. And then to sort of wrap it up, we're going to discuss the remaining rules. The important one being number 3. Number 3, basic conversion rule number 3 for the many-to-many relationships. Okay. Since what a utility data model does not have one of those, okay, we can briefly recall our sporting goods example, and many-to-many contains relationship between orders and product entities. The contains relationship becomes a separate entity, typically called order detail, and the primary key of this new table is the compound key consisting of order ID and product ID. Okay, so this is the one you're going to be running into a lot, just as much almost as the first two. The remaining slide on these conversion rules, slide number 17, is talking about the ones that they're less common, but nonetheless important, and we've have used some of them already. So rule number 4, in order they appear in the textbook, not necessarily in the order that we've sort of used some of them. So rule number 4 on identification dependency states that the primary key of the weak entity, such as rate, is a combination of the primary key from the rate set table, that's that rate set number, and the appropriate field such as min usage from the rate table. So we already did that. Okay, that is explicitly already the primary key of that weak entity rate is in there. Okay, and is a compound primary key with rate set number and min usage, just like it's shown over here. Okay, converting a weak entity into a strong entity, which we chose not to do, would have made this rule irrelevant, obviously, because there wouldn't be any identification dependency rule or a weak entity to convert and apply this rule number 4. So we could, so one can avoid this rule altogether, which is typically what is done. Conversion rule number 5 states that each one-to-many relationship with 0 minimum cardinality on the parent side. Okay, that is the bill includes reading, where the bill, okay, is not required. It's optional for this relationship. So before my recording abruptly stopped for no apparent reason, I was discussing a few of these remaining conversion rules that we are not going to use as much, or they're less common, but nonetheless important. I talked about the identification dependency rule number 4, and then conversion rule number 5 for optional 1 to m rule. Okay, so the bill is an example. Bill includes reading as an example of a relationship that could create a bill reading table with bill number and read number as a compound primary key, and then not allowing any null values for the bill number, which are currently allowed because the bill is optional for reading. And we then talked about the fact that readings can be can exist without being used on bills. This is generally not used, as this bullet is pointing out, because of added complexity with more tables and implementation issues and so forth. But it is useful for avoiding null values in foreign keys. Conversion rule number 6, we already use generalization hierarchy rules separating the customers into commercial and residential. I'm not going to talk about that one anymore. And finally, conversion rule number 7, we are not going to use at all. It's probably the most rare because one-to-one relationships are not used very often, and as such will not be used in class. Okay, so the summary. We refined our initial what a utility ERD with several useful transformations, finalized it with some error checking, and then converted the whole thing into an actual RDBMS by coding a set of SQL create table statements, which you can clearly see that it took some time, although I had it almost, had the structure prepared. Okay, so this is where the automatic conversions between an ERD into SQL are look to be really useful. So now, before we continue with the class projects and the assignment, we're going to take a break, and this is the last video of this series, and there's going to be one more topic on the database normalization, probably 2 video recordings, and then we are done.